All right, we're back. Now, I don't know if it's possible, maybe some of y'all can help me, but once I had it on a selfie mode for the video, I couldn't get it back to go the other way, so we have to break this up into two videos. But anyways, so we're talking about dilations, okay? Dilations. We're going to measure these and draw these. Oh, I don't think this is going to work. You'll have to bear with me. I'm going to have to use my computer here. Go back and forth to move the slides. Oh, actually, I can move it on here. I'm still there. Don't go anywhere. Try and find out where the pen is. Oh, we may just need to use my finger. Oh, well. All right. So, dilation. Okay, dilation is a transformation defined by its center P. And we had this too. You remember the rotations at a certain point. You rotate it about that point, and positive or positive or negative, depending on which way it would go. Same thing with we're going to dilate from a certain point, P. Same thing here. Okay, with a factor of K is greater than 0. Now, K is going to represent how much we're going to enlarge it. If it was K equals 3, that means we're going to make the same shape, but it's going to be 3 times larger than the original shape. All right, okay. Or it could be that if we're reducing it, it could be a fraction. Okay, it's always greater than 0, but like say for instance 1/2. Okay, well if it's K is 1/2, that means I'm going to make the object 1/2 of its original size. All right, we're going to show you how to do that as well. Okay, now here's an example of a dilation over here. Okay. You see how it's done? From point P, you've got the original object. Now, how we're going to do it is you're going to take your ruler and you're going to place it and you're going to make, or your straight edge, and it's going to go from the point and you're going to attach it to that point, and then you're going to go beyond. You're going to do that for every point. You see point C, point B. I'm going to go through B, so that's a straight line. From point P, that's where you're going to start your ruler, and you're going to go through point A and beyond that. Okay, and this is going to be the new image. You see there you've got the little apostrophe after showing the after image. You've got the pre-image and the after image there. You've got A, B, and C. You see an enlargement, and you look at it, and it is the same shape. All the angles are the same. It's just enlarged. So it's similar in that fact that all the angles are, it's just blown up. Okay, and we can do this. All right, and that one is a certain amount blown up. I'm not sure, but we'll show you how to make it precisely 3 times larger, or 4 times larger, or 5 times larger, or we can reduce it and make it smaller. Of course, it's going to be on this side, and we can make it half of its size, or 1/3 of its size, or whatever the instructions tells us to do. Okay, you have 2 types here. Enlargement, where it's greater than 1, like we're talking about, like 3 or 4 times larger. Okay, reduction, okay, this is where it's going to be in between 0 and 1. It's going to be a fraction, so we're making it, excuse me, excuse me. All right, we've got a fraction of the size, okay? Identity dilation K equals 1. Well, K equals 1 means, okay, if I take original size, let's say one length was 3 centimeters, and if I multiply it by 1, well, what do I get? I get back to the same shape, okay? And that's the identity when it's the same. You had identity properties in mathematics. For instance, one of them was if you take a number and you multiply it by 1, you get the same number. You get itself. Okay, same thing when we're talking about in geometry here. All right, example number 1. Find the image of triangle XYZ if it is dilated with the center P and K equals 3. So K equals 3, it means I want to make this shape, every side of this triangle 3 times as large as its original. Now bear with me. We're going to go over here, and I'm going to have to get to the computer to make sure that the ruler's on there just right. I'll try to talk while I'm doing that with the computer. So I'm going to leave the screen for a second. Don't worry, I'm all right. Just going over here to the computer. Okay, now I'm going to come back to the screen just to point this out. Okay, like I said before, now these will all be labeled. I didn't take the time to label them, but these would all have letters on it. I think it said triangle XYZ. All right, so here's the point. They're going to give you that point. What I'm going to do is I'm going to take my ruler and I'm going to measure. Okay, I'm going to put a line up here and measure. Now this was 1 3/4 length. You see that there, 1 inch and 3/4, or 1.75 inches. So what I'm going to do is I'm going to multiply that by 3. All right, see if here I can bring up a calculator off to the side here. So 1.75, we multiply that by 3, and you get 5.25. Okay, or 5 1/4. So what I'm going to do is I'm going to send this line, and maybe your line goes out farther than that. That's okay. Okay, but here you're going to put a point right there at 5 1/4 or 5.25 right there, and then you're going to make a dot right there. Okay, that'll be the dot. That'll be my new dot for that. And this is going to make every side 3 times larger. All right, so we have our dilation. All right, we're going to go to the next point and do the same thing. Okay, take my ruler. All right, now with this, hopefully this doesn't take too much time. Okay, I'm going to put my ruler, start it at that point there. Okay, we're going to line that up parallel to it so I can slide it right on there. Ooh, not bad, not bad, not bad. All right, so we look at this. Okay, we look here and we measure it from the point. I know mine's off a little bit here. We see here 3 and 2 tick marks there, so 3 and 2/8 or 3 1/4. So what I'm going to do is I'm going to take 3 1/4 or 3.25 in my calculator. Oh, my calculator disappeared there. Pull that up. And maybe I guess we won't have it zoomed in all the way so we can see both of those. And I can work on it on the board. All right, so I'm going to take our calculator. Okay, and we're going to see if I can work the calculator still on here without the menu. Yeah. All right, so we've got 3 and 3.25. Multiply that by 3. Okay, we get 9.75. All right, we look at this, and like I said, my ruler's a little bit off. When I did this, it was more precise. So I'm going to go 9.75 or 9 3/4. Mine goes a little bit further, and we're going to put a point there. Okay, and then we're going to do the last point the same way. Making sure to show you every one of these points just so that you understand. You do all of them the same way. Okay, line it up there on the point. Okay, try to get it parallel with the last line. Line it up here. A little bit off. Try to rotate that a little bit. Ooh. All right, I think I got it. Okay. All right, so we measure that. Okay, from the point to there is 1.5, it looks like. Okay, 1.5, 1.5. So we can multiply that by 3. 1.5 times 3, we get 4.5. So we measure that out. Our new point would be at 4.5. Okay, so now we should have points at the end of these lines. Okay, once we have that, we want to make our new shape. Okay, that will be 3 times as large. So I've already done this. I want to click on it. Make sure we're on the mouse here, but if I click on there, look at that. Okay, so we'll connect them, put dots here. Okay, go into there. Okay, put one here. All right. Okay, from here to here, connect it to our points, and then connect the last one. Come on, come on. It's in here somewhere. Ah, there we go. Okay, and then we see, okay, we've got a triangle now. It's the same shape, they're similar. Okay, just enlarged, and this one now is exactly 3 times as large as the red triangle. All right, that's a dilation. Okay, example number 2. The only difference with this, a couple of differences, is that we're not enlarging it, okay, we're reducing it. Okay, find the image of JKLM if it is dilated with the center M and K equals 1/2. All right, now, couple differences with this. 1/2 is a reduction, okay? Another difference is the center is at M. All right, we've had rotations like this too. The point is not off of it, the point is actually on it. So our point all is going to go from M. Okay, we go 1/2 M. M would just stay there. All right, everything else will be 1/2 of the length. All right, so to show you how we did this. All right, so my line is just going to start at M, which is exactly on it. All right, now we look at this, my ruler. Okay, my ruler measures, okay, about 2.5. Looks about like 2 3/8. So what we're going to do is we're going to divide that by 2. Okay, it looks like I did it about 2 1/4. So about 1 1/8. You see there that I put my dot there. Okay. All right, let me go ahead and move the ruler. So This is hard to do on the Mimeo, so I'm going to come over here. Uh-oh. Alright, this might not be enabling me. Alright, looks like we may be a little bit locked up. Okay, alright, no problem. Alright, so a little bit locked up, the ruler can't move there, but we're going to measure each one of those. We're going to measure this. From M to K, how long is that? Okay, half of that. You can see my dot is about half. Looks like I might be a little bit off. But we'll measure how far M to K is, and then half that distance where I'm going to put my dot to make it half the size. Measure from J to M. Okay, whatever that distance is, we're going to do half of that. Measure and put my dot there. Okay, then we're just going to connect all these dots. All right, not sure why this is showing up with the ruler, but that's okay. All right, we connect all those. Okay, and then we see, okay, we have the same shape, except it's half of what the original was. All right, so we have a dilation. There's an example of a reduction. Okay, the ratio of any image length to the corresponding pre-image length is equal to the scale factor. All right, the intersection of the lines determined by point image pairs defines the dilation's center. All right, so we're going to sort of work our way backwards, and we're going to find out where was the center, where was the point, given the following example. All right, find the scale factor and the center of the dilation. Is the dilation an enlargement or a reduction? I actually already have that on here. That's just talking about, is it getting smaller or is it getting larger? We see our original one here. This one is getting larger. Okay, it's an enlargement. All right, now, find the scale factor and the center of dilation. Okay, scale factor. Well, we look here, you've got one labeled 30 and one labeled 12. Well, what I told you was, just like the other ones, is that one length, when we multiplied it by 3, if we took each side and we divided the large by the small, you would get 3. That's the scale factor. So the same can be done here. We can take the 30 and divide it by 12 to get the scale factor. And I believe I've done that here. Let's see here if it's there. Yeah. Okay, 30 divided by 12, 5 divided, reduces to 5 divided by 2, which is 2.5. Okay, meaning that each side is going to be 2.5 times as large as the other. All right, now I believe I have on the next slide how we get that. Okay, all right, let me see if those can be taken off. No. All right, okay, they can't. We just got that on there. All right, hopefully we have that animated. All right, that's okay. All right, what we're looking at here, this is how you find that center. Where did it come from? Well, if you remember, we took it from the point before, and we connected to the two corresponding vertices, C and C, A and A, and that. So we're working it backwards. All we're going to do is we're going to take our ruler, and I'm going to put my ruler and make a line that goes through both C's, through both of the A's, through both of the B's, okay, the image and the pre-image. Okay, if we look at that, they all intersect at this point. So what we've done is we've found the point, working our way backwards, making the line go through those. Okay, so we found the center of rotation. Not center of rotation, I'm sorry. We found the center of dilation. Okay, I'm back on the other lesson. All right, graph paper. Okay, all right, these are just examples. That's it. All right, so homework assignment will be to do 1 through 25. We'll have opportunities where we can set up a conference on Zoom. Hopefully all of you are on that Zoom by now, but we'll have a conference where we all can meet together, especially on review days, just go over problems. You can ask your questions. I can show you how to do them. Sort of trial and error by that, but hopefully we get a lot of work done. I just feel free, if there's any problems with this videos, whatever, please comment on them, and we'll try to make this better. I hope you're having a great day. Like I said again, when you're not doing schoolwork, you got some extra time, there's always things to do. Some of you are great artists, some of you, are good with the woodworking and good with other different hobbies, but make sure you're doing these. This is an opportunity to be able to do these. We should thank God for that. Hopefully you're having a great day. Talk to you later. Bye.